Evening everyone. Thank you everyone for coming. Thank you for the introductions and the previous talk. So my name is Ben Hall. I am the founder of a company called Katacoda. We are an interactive learning platform for software developers. And so we are unique in the fact that we give you everything which you need directly in the browser. You have a fully interactive environment which has been pre-configured with Kubernetes and Docker, Kubeflow, and all of the technologies which you need to get started with. And you also get step-by-step instructions about how do you solve real-world problems. For example, how do you start something basic and foundations such as launching containers, up to how do you run Kubernetes across multiple machines and scale into cloud. And you can do that directly from your browser. And we work with different companies. We've worked, as we've described before, and Red Hat. We power their interactive learning platform. And so if you're interested in learning more about Kubernetes and other projects related to the cloud-native ecosystem, such as OpenShift, then there's interactive tutorials that we power and we support. And Kubernetes is kind of taking a world by storm at the moment. It's everywhere. It's got all of the major companies are backing it and providing it. All of the major cloud providers are investing heavily in making sure that they have a Kubernetes offering that is sustainable and supported and meets different workloads. And as we've seen from our beautiful hosts, they're already building on top of that platform because it provides that foundation. It provides the foundations about how we can go ahead and how we can deploy workloads of any different type at production, at scale. And so Kubernetes was born out of Google, so as many things have been recently. And it's, for Google, they have been deploying containers for the last 10, 15 years. And that's how everything within Google gets deployed. From your ad hoc MapReduce jobs and your machine learning work up to when you deploy an instance into Google Cloud. Under the covers, it's all running on a system called Borg, and Borg is how everything gets run inside of Google. But that Borg system was very heavily inspired by Google and how it works internally, and so it wasn't very applicable to how other companies could potentially use and deploy their workloads. And as such, Google created and initialized a project called Kubernetes. But they didn't want to be the owners, they didn't want to be the gatekeepers, they wanted the community to embrace and support this project. And so they donated Kubernetes to the Cloud Native Computing Foundation, a foundation supported by the Linux Foundation, which supports many of the communities, such as Cloud Foundry and OpenStack and Linux itself. So that other companies such as Amazon and Azure and Microsoft can embrace and extend and build it to match what their needs are. And so they have taken the project and taken the community by hold, and that's why it's been so successful recently. For example, it's not just about running workloads such as websites and databases, you can run serverless type applications. So if you just want to run ad hoc workloads, small little functions which sit there such as AWS Lambda, but you want to do it on your own infrastructure, then you can with things like kubeless. But at the other extreme, you can now run machine learning workloads too, such as with projects like Kubeflow. So the point of Kubeflow is how can you take advantage of what Kubernetes offers, which is highly resilient, highly scalable orchestration about about workloads and how they should run, and make it available to different types of workloads, and make it targeted to people who have requirements for deploying TensorFlow and Jupyter notebooks and other types of machine learning training activities. And so this is the aim and this is the intent of what Kubeflow is trying to offer. And as was just described, they recently came out with a new example about how you can go from having a Kubernetes cluster and deploy and train a model and then serve that model so that it can be integrated within your own applications. In this case, a beautiful GitHub issue summary which will take a random issue from GitHub and produce you a summary of what that issue is talking about, what the aims and ambitions of that summary are. And if you look at kind of what's happening in the covers, it kind of goes into some of the techniques that was introduced in the previous talk, but it's using some decoders and some TensorFlow workloads in the covers, and that model had been trained against millions of different GitHub issues, and then that produced a model which can be used by the application. But let's see how all of this actually works and how we can put all of this together and start deploying Kubernetes and Kubeflow and actually having our model trained and then served. So what we have is we have Katacoda. As I mentioned, Katacoda covers a wide variety of different technologies, so Docker, Kubernetes, machine learning, up to things like Docker security and how you run things at scale and in production. And when you come into a course such as Kubeflow and machine learning, we've got different technologies, different scenarios which will walk you through how we solve certain problems. And in this case, we're going to look at how we solve deploying the GitHub summarizer using Kubeflow. And so what we have is, we have our interactive environment and we have our step-by-step instructions. These will tell you what needs to be done in order to succeed and in order to solve this particular task. And so the first thing that we need to do is create a namespace within Kubernetes. The idea of Kubernetes is that we'll have all of our workloads running across multiple teams and multiple projects. And so what our infrastructure team can do is deliver us a control plane which is capable of running different types of workloads, different types of problems, and have that capacity always available. And so when you've got peak traffic on your website, you can dial back down your machine learning workloads and run them in the background. But when it's overnight and your traffic is lower, you can scale that back up and take advantage of any unutilized resources that you may have within your cluster without having to worry about managing different infrastructure for different types of teams and different projects. So by creating a namespace, we can keep everything organized and structured. And what we're now doing is using a tool which Kubeflow really likes called KSonnet. And KSonnet is a package manager. It's like what you use for apt-get or npm if you're on a node build or other package managers. But the idea is it makes it simpler and easier for you to deploy your workloads and solve the task that you're trying to achieve. So in this case, we're configuring our deployment and making sure that KSonnet knows how to talk to Kubernetes. And then we can tell it what we need to install. And so in this case, we're telling it what packages we want to be made available on our Kubernetes cluster. And so we install the core Kubeflow package, and then we install two additional things. We install a package which is designed to help with serving TensorFlow models, which is TF serving, and a task which is designed to help with running TensorFlow jobs, so i.e. training the model, called TF jobs. And so by having that in place, we can generate our template and deploy it. And so now we have a template which represents all of the configuration and all of the different problems which we're aiming to solve on top of Kubernetes. And instead of worrying about how do you create all of this different options and different configurations, we can focus on what our intent is and what the problem is that we're trying to solve. And so now we've got all of our configuration, all of our support within Kubernetes. And so what we've done is gone from a blank Kubernetes cluster, which had been deployed onto like Amazon or Azure or Google Cloud or on-premise, and we've installed the Kubeflow components. And if we ask what's running at the moment, we can see that these containers are starting up and all of our workload is being created, and the ones which haven't been available yet are just being downloaded and full. So we now have Kubeflow. Okay, great. So what can we do with Kubeflow on top of Kubernetes? And so as was introduced before, we've got this Kubeflow example GitHub repository, and within that we've got this GitHub issues summarization project. And we can use exactly the same technique that we did when we deployed Kubeflow to deploy this training model. And so if we zoom in a little bit to what these commands are, we can zoom out. We're setting up our environment, so where are we deploying our infrastructure to? We're setting up some secrets so that our workload, which we're running, our training model knows how to get data, in this case from Google, and then how to save the training model back into Google Cloud so that it can be used at a later date. And then we're deploying, setting up the security models and telling it what image to use. Setting our training sample size so that we know the sample size of our training set, and then configuring the parameters about where our workload sits. So in this case, the input data is in a Google Cloud storage bucket called Kubeflow examples. and it's going to be downloading a GitHub issues zip. And then once it's done the training based on that model, it will save the trained model into Kubeflow examples into something called output model.h5. And so as we're configuring our workloads, we're kind of configuring these different options and these different tweaks. We don't have to worry too much about the underlying details. Instead, we're just focusing on the high-level objective. We call apply, and then apply will go ahead and run that workload on top of our Kubernetes cluster. Go on top and say what's running. We can see that that container is now creating. Now, the beauty of this is that when we're deploying these packages and we're deploying these templates, we can have something which runs locally on our local dev machine, and that will be great for testing and development and making sure that our model is kind of behaving exactly what we need it to do. But when we want to scale and we want to run it across millions of different GitHub issues, we're not going to want to run that on our local laptop. And this is where Kubeflow allows us to take our local packages, our local templates, and deploy them onto something much more powerful, like GKE, which have got GPU support and all of the infrastructure we'd expect, and run exactly the same training, just on a much higher scale. So this will go ahead and this will now train our model. This may take a while, as training does. The dataset alone is about 3 gigs in size, so let's not wait for that. Instead, let's look at what happens post-training. Like what happens once we have our model trained and how we can integrate it into other applications and other deployments. And so in this case, we're going to install Seldon. As was mentioned, Seldon is a great way of serving our trained TensorFlow models. It comes out of the box within Kubeflow. So just as we were installing our core components for Kubeflow itself, we can now just add this additional package into our Kubernetes cluster, and now we have the capabilities of what Seldon provides, and we can use that to start deploying and extending, using that to deploy our TensorFlow model. And so again, very similar. This will be install, download, and run the core components that are required. So let's close that. And now we can deploy our model. So in this case, what we're doing is telling KSonnet to generate us a template. We're giving it the model, the base template to work from, in this case Seldon for simple, and giving it our nice friendly name of the project which we are looking at, and the project which we're deploying. So this is our nice friendly name, so we can refer back to it. In this case, image to summarization model serving. Give it some name so that we can refer back to it in Kubernetes, and then we point to it on the image, the Docker image that contains our trained model. And so I've gone ahead in the background and I've converted our trained model, I've packaged it up with Seldon, and I've pushed it onto our Docker hub. And so this contains all of our data and a Python app so that our model can be trained and other people can build on top of it. And so now we've deployed that. If we ask what's running, we can see we've got the core Kubeflow applications, so like a TensorFlow hub, so you can see what workloads are running. We've got our image summarization training, which is still creating because it's quite a large set. But we've now got our TensorFlow serving modules, which are running. And so we now have our image summarization service running on top of Kubernetes. And so now our clients, such as our web application, can call into that project and see results. And so that's what we can do now. This. Just make sure I'm going from here. So now what I've done is I've sent a query of just a JSON blob of a GitHub issue to our image summarization endpoint, which is running on Kubernetes, and then the JSON which we get back is the summarization about what that training model thinks. Now, unlike AlphaGo beforehand, I didn't have a huge data set to work with. So we can see that the training model still needs a little bit of work because it's not making perfect sense. But we can see how we can now start deploying this and start iterating on it. We can run the training, we can increase the sample size, we can give it more examples, and so that training module will improve and will increase. And we can deploy the website in exactly the same way. So if we come into here, using KSonnet, we tell it what packages we're interested in installing. In this case, we're saying apply the UI, give it a nice friendly name of front end to end, which could be friendlier. But now, based on that template, Kubeflow and KSonnet knows how to deploy all of the information and all of the dependencies required to get our issue summarization UI working. And so this is exactly what will talk to our trained TensorFlow serving model and become available. We need to set our GitHub token. And if we see that running, we can now see that we've got a UI running. And so without having to worry about the underlying infrastructure of what Kubernetes is offering, without having to worry about how do you create these pods, these containers, these YAML definitions, we're using a higher layer of abstraction so that we can focus on the train models and the workloads and TensorFlow itself instead of actual Kubernetes infrastructure, which is a much more interesting place to play. And so if we go to our GitHub page, if we go to our model, then we can run that. We can see that we get back a similar result. If we populate a random one, then we should get back and it will generate a different title eventually. And so we can now see that this is going against our currently trained model and going through Kubernetes and Kubeflow, and within 15 minutes we've managed to deploy everything. If we let that training run for a longer period of time and gave it more examples and let it run for a period of time, we can see that actually the train model gets much more interesting and the summarization gets much more accurate. So in this case, we've got a GitHub issue talking about E2E solutions using Kubeflow, and it's managed to correctly take that GitHub issue and produce a title which is much more accurate, much more reflective than what we previously capable of. And so by combining these different technologies, it makes it much more accessible for us to focus on deploying machine learning workloads with TensorFlow on top of an existing Kubernetes infrastructure, which we may have available to us within teams. And so what I quickly went through and what I quickly showed you was we installed Kubeflow using KSonnet onto our Kubernetes cluster, and so this installed all of the tools and all of the helpers required to get us started. We trained our model, which while it did take a while, if we kept that machine running and that workload running, eventually our model will be trained and we'll have the data set and the trained model pushed into Google Cloud Storage. We skipped ahead slightly and we started serving them a pre-trained model straight away. And again, by focusing on having our build container, which had our TensorFlow data, had our TensorFlow code there, we can start using it as an API and starting sending a request and getting responses back based on that infrastructure that we had in place. And then we can use, we can build UIs, we can build applications on top of it, and we can let Kubernetes focus on what it's really good at, which is how do I make sure that everything is scalable, how do I make sure that workloads are being run reliably, they're being run across multiple machines for reliability purposes. If we lose something, the workloads that are scheduled there get moved onto a different machine, and everything is happy and everything's hunky-dory. And as an operations team, we don't get 3 AM wake-up calls because a server has gone down and there's no one around to fix it. Instead, we have Kubernetes, which will fix it for us. And so the intent of tonight was not to demonstrate everything, it's too much to do within 15 minutes, but it's to give you a taste of the moving parts about where Kubernetes sits, where Kubeflow can extend it and support it can offer, and how you can get started to deploy these applications with these templating engines that sit on top of Kubernetes. And so if you want to play more, I highly recommend everything's available for free at Katacoda. Go to katacoda.com/Kubeflow and you can get started straight away within your browser without having to download or install anything. And with that, thank you very much, and I hope you found that useful. Thank you.
We've got time for a couple of questions, but those that do want to catch up with Ben, we recommend putting a beer in his hand first. But for now, if someone has a quick question, Inga, behind you.
So when you train a model, it's a lot about looking at the loss progression, looking at the loss in the training set, in the testing set, and looking at a lot of logs. Where does this investigation of training progression happen in your workflow?
So when the model is being trained, you would get all of the same output you would if you were training it using something like Cloud ML or another machine learning platform. And so as part of the learning process within Kubeflow, all of the logs and all of the output from the model is being persisted, and so that you can view that either in real time as it's happening, or at a later stage if you further push it up to the model, if I understand the question correctly. So that is all of the work which Kubeflow is putting in to the project, is making it easy to view logs and everything like that.
Any more questions? No? Left you stunned into silence? Wonderful. Okay, in which case, stick around, share a beer with us, perhaps put some questions to Ben and any of the team here at Seldon. It just remains for me to say thank you to Ben.